Hello learners, I am Dr. Munish Kumar Bhardwaj from the School of Engineering and Technology of IGNOU. So we were discussing about the damp proofing and waterproofing. In last lecture, I discussed about the damp proofing, in which I discussed about principles of damp proofing, procedure for damp proofing, detection of dampness, then causes of dampness, then prevention of dampness, and finally I discussed with you remedial measures and treatment. Now we will be discussing about the waterproofing, in which we will discuss about types of waterproofing, the two main classifications of waterproofing methods, integral waterproofing and surface treatment. Under surface treatment, we will discuss about various kinds of surface treatments. The objectives of this lecture are that at the end of this module, you should be able to explain the meaning of waterproofing, and also you should be able to describe various waterproofing methods. So let's begin with the definition of waterproofing. What is waterproofing? Waterproofing is the treatment of a surface or structure to prevent the passage of water under hydrostatic pressure. Presence of unwanted water inside a structure is a visible, annoying and a damaging element. It not only spoils the aesthetics but also damages the structural elements of the building. Waterproofing has to be provided to avoid the inconvenience caused by dripping ceilings, peeling off paints in wall and efflorescence, etc. Most waterproofing systems are designed for application on exterior surfaces, since they form a barrier to the entrance of water. The walls and floors provide the support system to counterbalance the hydrostatic head of water. But reservoirs, tanks or pools are waterproof to contain water, and here the waterproofing linings are installed on the water side of the structure. In these instances, the waterproofing is said to be applied to the positive side or the positive face. Means when we are providing the waterproofing on the water face, then we are calling it as positive side or the positive face. However, several waterproofing systems are designed to be applied on the side opposite to the potential source of water, that is the negative side, since the system also have the structural ability to withstand the hydrostatic head of water. Why to do surface treatment? Surface treatments gain importance because of the tendency of concrete to develop cracks due to the expansion and contraction of the surface on account of temperature fluctuations, shrinkage or permeability of concrete caused by improper workmanship or materials. Once the concrete or plaster has already started leaking, only surface treatment can make it waterproof without breaking and redoing the substrate. Surface treatments are also provided as a precautionary measure to avoid possible problems that may occur later in the concrete or the surface. Waterproofing treatments are broadly divided into two categories. First one, integral waterproofing, and second one, surface treatments. Here you see various types of surface treatments. Waterproofing may be of two types, integral and surface treatment, as I just told you. This integral can be divided into further different categories, that is permeability reducers, water repellents you can use, Then bonding agents can be used. In bonding agents, there are different kind of materials. First one is fine particulates densify cement gel. Second is plasticizers. Third one is accelerators. Whereas under the category of surface treatments, you will find different methods. First one is brickbat, coba and tiling. Second one is capillary crystallization. Third one is tar felts polymer sheets. Then last one is protecting coatings. Under the protecting coatings, the various materials used are epoxy, bitumen, rubberized materials, then silicone, then polyurethanes. So these are different type of surface treatments. We'll study about these one by one. First, let us take the case of integral waterproofing. It involves the use of admixtures and additives like plasticizers, superplasticizers, air entering agents, waterproofing components, bonding agents, etc. at various stages of construction itself or while repairing. The use of these products improves the workability of the cement mix with a lower water cement ratio, making the concrete waterproof. So that is why these are called as the integral waterproofing systems. Now we move to surface treatments. Surface treatments are normally done after the concreting and cementing work is completed, or even after the completion of the whole building. The object is to treat the surface subsequently, overcoming the defects and making the surface waterproof. What are various types of surface treatments? Surface treatments can be categorized into the following categories. First one, brickbat, coba and tiling. Second one is tar felts or polymer sheets. Third one is capillary crystallization, and fourth one is protective surface coatings. First we begin with brickbat, coba and tiling. What we do in this? The surface of RCC slab shall be wire brushed and cleaned of all dust and foreign matter to lay brick jelly concrete. Brick aggregate shall be obtained from well burnt hard broken brick and shall generally be varying in sizes from 20 mm to 50 mm and well graded. Underburnt brick shall not be used. Brick aggregate shall be soaked in water for a sufficiently long period before mixing the lime. Brick jelly concrete shall be made in the proportion of 1 cubic meter of brick aggregate to 0.37 cubic meter of slag lime. No sand shall be added. The brick jelly concrete shall be used when it is quite fresh. Brick jelly concrete shall be spread over the slab and the surface shall be formed to slopes as required. It is intended that the finished thickness of brickbat, coba at the lower end of the slope, that is at the point where the thickness of coba is minimum, shall be about 20 mm to 25 mm. Consolidation shall be done by beating the surface with wooden beaters weighing about 1 to 2 kg, and beating shall be continued till the beaters rebound readily and do not make any impression on the surface. During the process of beating, the surface shall be constantly kept wet by sprinkling with a mixture of jaggery, that is good, and boiled solution of stone apple, that is bale fluid. This mixture shall be prepared at least 10 days before it is required or used. After brick jelly concrete has hardened, or after 6 days, a layer of flat tiles, that is machine press tiles, of approved thickness shall be laid in cement mortar of 1:3 mixed with crude oil as described here. How we will do it? I'll describe here. The surface shall be roughened and cleaned of all dust and other foreign matter. Then it shall then be wetted before applying the mortar. The flat tiles shall be immersed in water for 2 hours before using. The cement and sand shall be first mixed dry. The cement shall be weighed for each mix to ascertain its weight in order to fix the quantity of non-volatile crude oil to be added, which should be 5% of the weight of cement. The dry mixture shall be worked up well with the required quantity of crude oil and then water added and the mortar further well worked with trowel. The tile shall be bedded properly in this mortar with joints of about 8 to 10 mm width with their longitudinal lines of joint truly parallel and horizontal and at right angles to the transverse joints. Before the work dries up completely, the joints shall be raked out and pointed over with cement mortar of 1:3 ratio, and that also mixed with crude oil. The crude oil being 5% of the weight of cement. The joints shall be well wrapped over with thin bar towel and the excess of mortar scraped off until the surface of the pointing attains a black polish and become hard. The tile work shall be cured for at least 7 days, during which period it shall be suitably protected from any type of damage. Nowadays, instead of brick coba, well burnt brick bats are arranged over the concrete slab of roof, providing sufficient slope towards the roof drainage pipes, and the interspaces are filled with cement mortar of 1:3 ratio and also mixed with waterproofing chemicals, and the top plastered with the same mix and thread lined to avoid surface cracks. Next surface treatment is tar felts or polymer sheets. This type of treatment involves the laying of factory made sheets or felts which are available in rolls of specific width. This is laid on the surface over a layer of molten tar or similar adhesives and overlapped at the joints. At joint, it should be overlapped. The entire surface is thus covered with the sheet. Here there are some problems. Joints are vulnerable part of this treatment, apart from the weak bond given by the bitumen. Another one is water which may enter from the joints or punctures may subsequently cause blistering and puncture of the felt. Another problem is that the use of surface is also restricted because there are chances of puncture, so you cannot use the surface. You cannot walk over. So the use of surface is limited, restricted. Further, bitumen, which is a petroleum byproduct, is devoid of necessary oils and plasticizers, and it reduces its effectiveness. Weathering, ultraviolet radiation and temperature changes also cause deterioration and brittleness of the tar felt, which results in cracking. The built-up membranes are essentially bitumen saturated felts and asphalt or coal tar coatings to produce a layered system that protects a structure from water penetration. In a built-up membrane system, the felts are used as a reinforcement to stabilize bitumen layers. They provide the strength required to span irregularities in the substrate and to distribute strain over a greater dimension, greater area. Felts are bitumen saturated and they include, first one, organic felts. These are made from wood fiber pulp to which scrap paper and a small percentage of rag have been added. Second one, inorganic glass fiber felts and glass mats. The organic felts are saturated with coal tar, pitch or asphalt. The glass mat felts are treated with asphalt or coal tar. The remaining felts are saturated with asphalt. Overheating bitumen during application results in the loss of oils by distillation and produces a thin film when applied that doesn't provide adequate cementing action. So care should be taken that there should be no overheating of bitumen. The temperature range for heating coal tar pitch is 325 degree to 375 degree Fahrenheit, and for asphalt 400 degree to 430 degree Fahrenheit. Underheating below this range results in a loss of application workability and cementing capability. So both the things, overheating or underheating, in both the cases there are problems. Now we move to that how it can be applied. What are different ways? First is single ply materials. The problem associated with built-up membrane systems gave rise to the development of synthetic sheet single ply systems. Sheet membranes are generally available in roll form in various lengths and in widths of 1 meter minimum and thickness of about 30 to 60 mm. Joints in single ply system are made by heat, fusion, torching, solvent welding, tacky tapes or adhesives. These are the methods available for jointing. Single ply waterproofing materials are costly items and hence are used only in special environments like ultraviolet radiation, ozone and high temperature, etc. Different materials used are neoprene. This is the oldest of the synthetic rubbers, having been introduced in early 1930. It is based on polymers of chloroprene, ethylene propylene diene monomer, EPDM. This synthetic product was introduced to overcome some of the shortcomings of butyl rubber. The third one is chlorinated polyethylene, CPE. These sheets are available with or without polyester reinforcement. Next material is polyisobutylene, PIB. It is a waterproofing synthetic material generally bonded to a non-woven synthetic felt reinforcement that permits installation using asphalt or contact adhesives. Next material is polyvinyl chloride membrane, PVC membrane. It is made of PVC resins and plasticizers and is available with or without reinforcement. Some non-reinforced PVC will shrink as much as 5%. So care should be taken. It is not compatible with tar or asphalt. Lap seams are made by solvent welding and sealing. Next is modified bitumen or laminates and composites. In addition to synthetic membranes, there are proprietary single ply membranes that are made by the addition of rubberizing ingredients to asphaltic materials. In the manufacture of modified bitumens, a synthetic polymer such as polypropylene or styrene butadiene is blended with asphalt. So this is the composition of this type of material. Now we move to the third type of surface treatment, that is capillary crystallization. This process involves the application of liquid chemicals on the surface of the concrete. These chemicals enter the pores of the concrete or plaster and thereafter they crystallize, thus reducing and sealing the pores. One major limitation is that the concrete or plaster is prone to further damage, development of cracks, wear and tear, and possible leakage. Fourth type of surface treatment, that is protective surface coatings. Waterproofing by the use of surface coatings is the latest type of treatment. It is popular due to its effectiveness and ease of application apart from the economy of use. However, proper care in selecting the adequate treatment and its proper application play an important part in effective waterproofing. Protective coatings are generally based on epoxy, bitumen, rubberized silicones, polyurethanes, etc. These are the materials which are used for this type of coating. Liquid applied systems are available in both single component types or two component types. They are applied by brush roller, squeegee, trowel, or spraying to form a seamless waterproofing membrane. The single component type solidify through evaporation of a solvent or water or by chemical cure. The two component type solidify by chemical cure. The uniformity of thickness and freedom from bubbles and punching obtained with the liquid system is a function of the quality of work involved and the surface roughness of the substrate. Now let's see what are different type of materials. First is epoxy coating. Epoxy coatings have very good bonding properties with the substrate and form an impermeable membrane over the entire surface. But despite their good abrasion resistance properties and resistance to mild acids and chemicals, epoxies, being rigid in nature, cannot withstand the expansion and contraction of the surface and they develop cracks. This is the problem. Also, epoxies are not recommended for external applications due to their weak resistance to ultraviolet radiation. They are also very expensive. Now we move to another type of coating, bitumen based coatings. Bitumen based coatings are normally modified with polymers, oils and plasticizers and can be considered as an economical method for waterproofing. The additive only give limited resistance to heat, ultraviolet radiation, etc. and the treatment tend to become brittle, leading to crack formation. Now let's move to another type of material, rubberized compounds. Rubberized compounds have good elasticity, easily bond with the surface and expand and contract without cracking. These compounds, however, deteriorate fast with the effect of ultraviolet radiation and ozone, causing loss of these very properties. Which properties? Elasticity, good bond, good expansion and contraction properties, and hence they make the system ineffective. Now we move to another type of coating, silicone based emulsion and coatings. These are colorless coatings which do not change the appearance of the surface while making the surface water repellent. But their biggest drawback is the lack of crack bridging capacity. Silicones are thus not suitable for flat terraces or horizontal surfaces. At the most, they may be used on vertical walls for water repelling. Next material is polyurethane coatings. These coatings are by far the most effective surface coatings available. They allow for good adhesion to the substrate, forming a monolithic membrane which is totally impervious to water and has the elasticity to withstand expansion and contraction of the surface. UV resistance, resistance to mild acids, salts, etc. help polyurethane coatings to withstand external forces for longer periods. So in this lecture we discuss about the waterproofing. The two types of waterproofing methods were internal waterproofing and second one was surface treatment. In surface treatment we came to know about various kind of surface treatments, that is brickbat cobind tiling. Second one was tar felts or polymer sheets. Third one was capillary crystallization, and fourth one was protective surface coatings. Now after this you go through the text. In the text you will find sketches showing incorrect and the correct way of damp proofing and waterproofing construction. There you will also find some case studies on waterproofing, and also you will find spectrum of other waterproofing materials and systems. So please go through the text and enrich your knowledge. Thank you for watching.